Christopher, welcome to Talk Python. Welcome back to Talk Python. Good to see you,
Thank
man.
you. Third time's the
Oh,
charm. We'll see how it goes.
it's gonna go well, I'm sure. We got a really fun topic lined up, and I think this is one of those kinds of shows where there's going to be something for everybody. There might be a lot for some people, and there's going to be like, oh, that's the thing that made it worth listening, because we're going to talk about a bunch of different extensions, tools, techniques, etc. for working with Polars, one of the exciting data frame libraries that we have these days. So super excited to have you here to tell us about that. And I'm really interested to hear how it works with Django, because that's what you talk about when you come here, right?
I
I'm just
honestly,
kidding.
I haven't done it. There's no reason it shouldn't, but I have yet to actually combine the two pieces together. So,
Well, I have used Flask and Pandas together, so I'm surely Django and Polars will go together. I know
shouldn't,
actually that they would.
shouldn't be a problem. I think it's one of the beauties of these kinds of libraries is, at the heart, although they're Rust underneath or other things underneath to get you the performance, they're still just Python. So you got access to the code and you can do what you want. So
Yeah, I think there's probably some combinations that people don't typically think of. Like, for example, one of the things that I like to do is I've got some dashboardy thing, either for Talk Python in the courses, I can't remember, but I want a bar graph. And so I do some matplotlib thing and have it generate a picture and just return that as a picture dynamically at a URL, and just set the source to the image to be wherever that thing gets generated from. So there are really cool combinations, though I suspect we will not be doing much of our typical web stuff this show, will we?
I'll drop mentions to my book because I have to. That's the way it's supposed to work. But otherwise, yeah, we'll stick to the data science world this time around.
Yeah, well, let's start there. I know people probably have listened to you on the show or on the Real Python podcast or in other places that you're doing all the things. But, tell us about yourself. Feel free to mention your books so people know about them as well.
There you go. Yeah, there's an old joke. How do you know somebody runs a marathon? Well, they'll effing tell you. Well, authors are more or less in the same package. It's a contractual obligation. So
It is. I wrote about it in my book, Chris. Have I
there you
told you
go.
about it now?
Exactly. That's right. And I guess while I've got you on air, thank you for writing the foreword. So yeah, it's I guess now I should sell myself as an author. It's nowhere near as impressive as people make it think it's sound to be. I guess I spend my spare time doing sort of Python education-y stuff with you and other organizations, and writing is kind of part of that. My day job is still helping organizations do technical stuff. Sometimes that's architectural advice, and sometimes that's things like agile and lean and process-driven things. My marketing people tell me to sell myself as a fractional CTO. I have a hard time saying that with a straight face, but got to put it on the brochure. So there you go.
Well, if you don't want to take it so seriously, you could be an improper fraction.
There you go.
You could be like a 2-ace CTO.
I'm an irrational CTO. That actually makes sense.
I'm radical 2/7. Let's go. That's how much a CTO I am. More seriously, though, I'm sure there are people listening who find that idea pretty interesting. Fractional CTO or sort of fractional something beyond just like low-level coder. Tell people what is that like? How do you get into that?
I got into it because I kind of fell into software management early on in my career. There was a company I was at where it was a Windows-based shop, and I was hired as the Unix guy. That we all had this naive idea that we could port the product to Unix easily. So I was their sole Unix architect person. After about 6 months worth of work, we figured out this just wasn't going to happen. And my VP got pregnant and went, "Want to be a manager?" and basically handed me the keys.
Wow.
So I kind of learned by being thrown in the deep end as to sort of how to do the technical management type stuff. So my career has always kind of been a bit of a balance between that. I like smaller organizations and I like helping them grow. So what that tends to mean is when it's really early on, when you're number 2 or 3, you're coding like a line developer. And as the organization grows, you spend less time doing that. And because I've spent a lot of time in startups, I've done that journey many times. So the fractional CTO idea essentially is to try to help smaller organizations that wouldn't necessarily be able to afford a full-time CTO with that kind of thing, and sort of provide the kind of advice from things I've learned throughout that process over the years, and then sort of help out as you go along. And sometimes that's that's come in with a very specific target of help us architect something, and sometimes that's more of a we need some. It's sometimes referred to as adult supervision, where somebody comes in and just sort of advise, offers sort of the process advice, right?
Right. Who's going to be this adult in the room that says, no, we're not rewriting that in a new JavaScript framework for the third time this year?
Yeah, and often it's very hard in a startup to concentrate on things like CI/CD and testing and all the rest of it, because you're trying to get to market, so it's all about those features. Well, if you don't balance that, it's going to bite you later on, right? So I try to help with sort of that overall bigger picture as part of the organizations and get them going.
Cool. Yeah, I find even outside of that kind of stuff, sometimes it's hard to focus on the boring but important features that matter, rather than like, hey, wouldn't it be cool if we refactored this or made that faster? Like, it doesn't need to be faster yet until you have more customers. What you need is this other thing, this PDF export that nobody wants to write.
Yeah, and as developers, like the entertaining part of our job is learning the new thing, and oftentimes that's learning the new library, and sometimes that's great, and sometimes that's wasting a whole bunch of time because the old library would have been just as good, and keep sort of plowing along, right? There's a phrase that I stole in my book. See, I keep bringing it back to the book. People talk about Django being old, and it's like the difference between, it's a dinosaur. No, it's a shark. They're still around. They're still valuable. They're just as old as the dinosaurs, but they're still part of the ecosystem. And
interesting.
Hopefully, the gray hair at the temples here helps me provide a little more insight into that than, say, somebody fresh out of school.
Mm-hmm. Yeah, you see those gray hairs? That's C++.
Exactly.
Yeah, indeed. Okay. Well, let's talk data science and let's talk polars. So I guess there's a lot of people who have heard of polars and are experts. I see out in the live audience already, there are some folks whose things they've created for polars we're going to talk about in this show, actually. So
great.
Some people need no introduction to polars, but there are many people who listen to the show who are just getting into Python, using this as like one of the footholds to kind of get a feel for the space. And they might go like, what is polars?
Sure.
So what's a data frame? Like, tell us about this.
Yeah, I was about to say, before we get to the data polars, maybe we should just start with a data frame. So a data frame is kind of a in-memory spreadsheet sort of thing. It's a data structure that consists of rows and columns. And you do the same kind of things that you might do in Excel, but in your code. There are a whole bunch of advantages to doing it in your code over doing it in Excel. And in fact, the course that we're going to talk about gets into some of that. But there are a bunch of different libraries out there that help you do this. The big one that has been around for probably the longest and is the most popular is Pandas. Pandas has made some interesting design decisions, and as a result, there are some other more recent additions to the space that are trying to address some of those things that Pandas has done. And polars has become one of the more popular ones. I saw just as we kicked in here, there was a comment already about, I like the coding style of polars better than Pandas, and this, to me, this is also why I actually prefer polars. The interface to it is a lot more like object-oriented code, and it feels more Pythonic to me. And as a result, it tends to be one of the libraries that I now head towards if I need to muck with a bunch of data and do those kind of data framey things. It is almost every benchmark out there has marked it as being significantly faster than Pandas, so that's a nice little advantage. And it also includes methods to convert your data into Pandas and other data frames as well. So if you do get stuck and there's something that isn't there, and because it's a newer library, you can always just go, oh, give me the Pandas version of this, run my Pandas commands, and then bring it back into the polar space where you might be a little more comfortable. So it's a nice...
It's two pandas and a from pandas sort of thing.
Yeah. Yeah, and so it's a nice flexible sort of approach, and it's a quick bear. And one of the things I find, I'm not trying to dump on pandas. It's going to sound like that occasionally, but I really do. I like the library. It's very, very powerful, very, very useful. It uses a lot of black magic, and I find as a developer, as somebody with a software engineering background, sometimes code can be distracting where you look at it and go, how does that even compile? What is that? What are they doing? And that pulls me away from I'm trying to do something. And I find some of the stuff in Pandas kind of falls into that bucket. Whereas you just do nice little chained function calls in Polars, and so you're reading, filter, select kinds of things, and it feels a lot cleaner to me. So it tends to be where I want to go. And then the other big advantage of it, which some of the other data frame libraries have, but Pandas, as far as I know, doesn't, is lazy evaluation. And this is the idea of, rather than executing each operation as you call it, you can chain a bunch of things together and then call them all at the same time. This tends to give you large amounts of speed up. So for example, if you're reading in a CSV file and you want to do something only on certain rows in that CSV file, the filter can throw out those rows that aren't important, and then you would only run the operation on those rows that you were interested in. And of course, that tends to be an awful lot faster than going through every single row at a time. It also tends to use less memory for the same reason, because you don't have to keep as much in memory at any given time. So lazy evaluation can be a really, really powerful tool, particularly if you're using with really, really large data frames. So that to me is, the coding style was a nice selling point, but being able to see that performance difference with the lazy evaluation was really what hit it home for me.
Yeah, they're both super cool. I talked to Richie Vink, who is a creator of Polars, about 3 years ago or so on the podcast, and it was very interesting to talk about some of the philosophies.
Mm-hmm.
So, for example, the lazy evaluation is great because you could theoretically change the order. Like if I'm going to do some complicated math computation on a thing,
Mm-hmm.
we'll talk about some of those, and then I'm going to filter it down based on some unrelated criteria like state or whatever, gender, who knows, and then get the answer. If I did that in Pandas, it would do the math on every single thing and then filter it down and give you the answer. And maybe take the US as an example, that might be 1/50th of the data that you wouldn't have to multiply. So with Polars, it can even optimize. Well, if there's a filter, do the filter first and then the calculation. Right. Yeah, so it's got kind of an optimizer built in there as well.
Yeah,
so
this technology is very similar to what happens in databases. So if you're doing more complex SQL, behind the scenes, the database for you goes and tries to optimize that to try to figure out what the best way of doing this for you. And Polars has that built in as well. It's got it built in on your calls specifically, so you can take advantage of that even if it isn't the lazy evaluation. But it can really, really shine in the case of lazy evaluation. So if you're doing a complex query all in one chunk, like a group by with a bunch of different aggregates, it does still do the same thing, which again gives you one of the ways that it'll speed up. But particularly with lazy evaluation, where you might chain together 15 or 20 calls, it'll figure out for you what the best order on that is, and that can make a big difference. You can also see what it wants to do and how what its execution plan is. I don't understand the output. It's deep relational algebra. Yeah. But for those who are into this stuff, you can actually see exactly what it's doing, and it gives you a little peek behind the curtain.
Yeah, with databases, there's usually some way to ask for what's called an explain. Like you got some query, instead of saying run the query, parse it and do the optimizer, and then tell me what you would do. And that can be really helpful for saying like finding an index or something.
Yeah, and in fact,
is it actually using this index or is it not? But then there's something like that in Polars as well, yeah?
Yeah, and it calls it explain as well. So when you've got the lazy object, you can call explain on it, and it'll show it. It also has a graphical equivalent, so it'll spit out a little image, that sort of flowcharty kind of thing that shows you what it is as well. So if you prefer the pictures over the obscure Greek letter references, then that can show you what's going on.
Yeah, very nice, very nice. All right, well, we are going to not talk about the exact subject of your course that you wrote, but I think we should maybe give it a quick shout out. So your course that you wrote at Talk Python is Polars for the Power Users, Transform Your Data Analysis Game. What we're going to talk about is a bunch of different cool tools that extend and power up Polars, but if people are interested in learning Polars more from scratch, they could take your course. So I'll be sure to link to that in the show notes. Maybe give people the super quick rundown on what's on the course, and then we'll talk about all the items.
Sure. As you might guess from the title, it kind of teaches your polars. And you can see on the screen there's a bunch of different icons as well. What we're trying to do is essentially take you to that next step. So if you're doing data science-y stuff in Excel and you're trying to figure out how to move to the Python world with this, then this is kind of the course to try and help you do that. And it does it through the Polars library. So there's a whole bunch of different examples as you go along. A lot of the examples will start with, hey, here's a spreadsheet. Here's a thing that you're doing in the spreadsheet. Here is how you would do that with the Polars library and Python code instead, and why you might do that instead of doing a spreadsheet. Polars has this concept of expressions and filters, and they're the ways of performing operations on your data and then looking at different columns or different rows. So the course starts out there and then starts getting even deeper into real world examples. The final lesson is actually a case study. We took a bunch of the data from GDP data from the United Nations and showed you how to clean some of it, how to combine it. Whenever you've got data in the real world, even if it's from the same source, you're going to go, oh, I want this information from this column and that information from that column, but they aren't related. So now we have to cross-reference. So it covers how to sort of do all of that kind of stuff. So it's sort of this journey of how do you take some of the more basic CSV and Excel type stuff and change it into Python, all the way along the line to how do we actually create a report on data from the real world using Polars as your library for doing it.
Excellent. Yeah, it's also very funny. A very funny course. I enjoyed it. Okay. Polars is pretty awesome, wouldn't you say?
Yes, that's a nice, there you go. How's that for a segue?
Pretty awesome. In fact, let's reverse that. We're going to talk about awesome Polars. So there are so many of these awesome lists out there. And, if you are interested in something and you haven't looked yet for an awesome list for it, go do that. There's got to be an awesome Django. I know there's got to be an awesome Flask, and there's an awesome async. There's an awesome Python. And DData has gone and created awesome Polars. So what we're going to do is we're going to go to this curated list and pull out 10-ish number of things that we think
on the
would
order
be really
of 10. Yes, we didn't count. Yes, one of these days we'll start prepared.
Well, my tabs scroll off the screen, so I can't even count them. So there we go. But no, it's something on that scale. We're going to go through a bunch of different little things that are great. And for me, I just, like I said at the opening of the show, I really like these because it's like, oh, it's not a big deal, but it just made all of my work way easier and is really easy to adopt. A lot of these things are actually not huge commitments. It's not like redo your data stack in some other data frame library because you'll get some benefit. Like, no, you just plug this thing into your Polars work you're already doing, and it's really good. So with that, let's start out on visualization. What do you think?
Sure. Yeah, and this one's almost independent of Polars. I guess there's sort of this whole category of things that are already in the data science space. And what is specific to Polars is the good news, which is Polars works with all those tools that you're used to working with. So if you're already playing with Matplotlib or Seaborn or any of those, Polars will integrate with it just like Pandas does and most of the others. Polars does have sort of specific integrations with Altair and HVplot. So there's built-in calls on the data frame that essentially say, go plot this, and they will use those tools. But even if you don't want to use those, getting at a column, slicing a column out, and then handing that column down to Matplotlib works more or less just like Pandas does. So this integration works quite nicely. Likewise with tools like Jupyter or Marimo. Again, this isn't really Polars specific, but there's nothing in Polars that stops you from using these tools. And so, you're not if you're moving from pandas, this isn't a stopper. All the other things, you don't have to learn everything else from scratch. Everything you bring with you will continue to work without any problem.
Yeah, so on the Polars docs, we've got examples for hvplot, matplotlib, plot9, seaborn, plotly, all these things, and yeah, they look great.
Have you played with Altair much?
I've not played with Altair much. I think I've done mostly plotly and seaborn lately.
Okay, yeah, I have a love-hate relationship with matplotlib. I'm usually too lazy to learn anything else, and I grumble every time I use it because I can't remember how to set x underscore or set underscore x, and it drives me crazy. But gives you results, and that's what's important.
For sure. So you mentioned it, Marimo. I recently talked with Akshay from the Marimo team. I'm impressed. I am super impressed with the way that Marimo came out, the way it looks. It seems like a really nice, just a very nice modern Jupyter style. What do you think of it?
So I've yet to play with it. I've done a bunch of reading on it. The theory behind it is something that is beautiful to me. I actually don't use Jupyter, and this big stopping thing for Jupyter for me is it doesn't feel like it scales. And that's because the cells are stored as JSON. So it's a great tool like a REPL, where if you're experimenting with something, it's fantastic. But as soon as you're trying to start doing that on a team, it can be problematic because now you're trying to merge those JSON pieces. It doesn't work very well. And Marimo has essentially tried to solve this from the ground up. Instead of creating JSON to store everything, it's actually creating Python output, which means the documents that you're creating in Marimo actually can be managed just like any other code. And although I haven't played with it myself, the theory behind that to me is very, very beautiful. And the next time I dive into this space, this is definitely going to be the one I'm going to be playing with.
Yeah, it looks great to me too. I think even just from a visual, like the way the UI works, I really, really like it. The other thing, in addition to the Python backing instead of the JSON backing end, as in file storage, is the reactive bits. Like one of the things that always scares me about notebooks is like it can go 1, 5, 2, 7.
Yeah.
And you don't even know what happened into the like number 6 one, right? But it affects the way the notebook runs. Like it's kind of like go-to statements, but you get to pick randomly. And this has a way to say these cells depend in this order, and so there's a automatic refresh and stuff. Anyway, bit of a diversion, but I think it's worth paying attention to. Okay, where were we again? Well, next thing we want to talk about is Dataframely, declarative Polars native data frame validation library.
So the data science, the first 80% of your work is cleaning the data and getting it into the right shape. And then the second 80% of your work is coding. And then there's that last 80% of the work, which is output. I think my math might be off there.
It feels like it's right though.
It's the reality is true though. And what Dataframely helps you do is that first 80%. So this is from a group of folks called at a company called Quantco, and they're a data science consulting firm. And it works a bit like Pydantic or Django RM. See there, I brought it back. There's a book on that. So you can create a data class-like object here, which inherits from Dataframely's schema class. And inside of that, you declare what your expected columns in a data frame are. So for example, you could specify a weight, something that is a weight, like heavy or light is a float value, and an American zip code is a string. And in addition to that declaration syntax, you can also write rule methods on the class to give you more complex validation code, like this plus this have to be, these two values have to work together, or these two values have to be unique, or those kinds of validation pieces. Now, once you've got one of these schema objects, you then call its validation method, passing in your data frame. And if the results are clean, you get back your data frame. And if they aren't, you get an exception that describes each validation, telling you what rule failed, what rows it failed upon. And there's also a soft validation mechanism called filter, which returns a data frame with the rows that passed, and a failure info object with the rows that went wrong. So if you don't want to just sort of stop because it's too bad, you want to react to the parts that aren't, you can dig in and sort of go from there. So this is a nice little piece, and it can definitely help you. It doesn't fix the dirty data, but helps you detect it, which of course is your sort of first step as you go along. And
yeah, one of the real challenges you can run into is the data, it parses or something, right?
yes,
And so then math works, but at the same time, that's not necessarily giving the right answers. And you got to figure out, well, why is this not working?
yeah. In
What
fact, in
else?
the course, one of the examples we use, which is what you've got up on the screen here as well, is oftentimes people will put an American zip code, which for our non-American friends is a 5-digit number, or could be a 9-1, but that's just makes it messy. But let's stick with the 5 digits for now. Well, it could have a leading 0. Well, if you've stored that in, say, Excel as a number, then that leading 0 gets chopped. And now all of a sudden you've got this 4-digit thing, which isn't a valid zip code. And so as part of your data cleaning, you have to detect that. Or as part of loading the file, and you might have to say, hey, wait a second, this shouldn't be an integer. Please load this as a string. And so what these validation mechanisms allow for you is to help you sort of catch this. And so, for example, if you were processing that failed info object, and the only things that failed were zip codes, well, then you could have some code in there that went, okay, I'll just make sure that I fix the padding on this and maybe deal with it automatically as part of your data pipeline.
Mm-hmm. Yeah, and you could do something like this to catch it potentially. It's weird how the shadow that Excel casts, especially onto the data science world. You know, I'm thinking of how, or even science in general, there was some gene, as in,
I was just about to mention the same example.
I think it was like MAR 223 or something like that. But if you put that into Excel, it's like, oh, March the 2nd. You're like, no.
That's a date. Yeah. And in fact, even Polars to a certain extent has some of those kinds of problems. The routine that you use to read in a CSV, because CSV files don't actually have data type information inside of them, it essentially makes a guess. And it uses, I think by default, it's like the first 1,000 rows of the file to make an educated guess as to what the data types are. And what can happen is, let's say your data is consistent in the first 1,000 rows, and then row 1001 has something else. Well, then it's going to die, because it'll say, whoa, this is an integer, and now you're giving me a float, and because it didn't detect that this was supposed to be a float in the first place. Now, the difference between Polars and Excel is Excel will just keep chugging along, and you may not discover that you've caused yourself this problem, whereas Polars actually expects those columns to be a data type, so it'll scream, and part of your data cleaning process would be to catch those kinds of things and fix that.
Yeah. I mean, spreadsheets are awesome. They're really cool, but they get overused. Like I was doing something where I had a bunch of dates in a column, and I'd selected all of them just to copy them. But at the bottom it says, here's the sum of this or whatever.
Yes.
It told me like the sum of these 20 dates was like March 12th of some. I mean, Nope, don't think it is, but okay.
Yeah.
If you
the beauty of the spreadsheets is they're very, very flexible, and the pain of a spreadsheet is they're very, very flexible. And
exactly.
So it's you could end up missing some toes depending on where you're pointing the gun.
Yeah. So one of the challenges, for example, with your zip code example, is maybe the first 1,000 rows are West Coast people, so every number looks like a 5-digit proper number. But after that, you get to East Coast people, which start with zeros, because it goes old to new, I guess, is the way they came up with it. And that could be a challenge, right? Even just simple stuff like parsing that. Yep. Okay, what is up next? Shall we go onto the patio and have this conversation?
Yeah, so essentially, just as a quick aside, there are a couple different libraries that essentially do the same thing as what we just talked about. Patito. I'm not sure how you're supposed to say this, which is wasn't actually on the awesome Polars list, but it's one I've come across before. This is by Jacob Gerard Martinson, and it's built on top of Pydantic. Like with DataFramely, you declare a class inheriting from a model, then validate against it. The twist on this one that I kind of liked is it also has a mechanism for generating data. So if you're writing unit tests, once you've got this validator, you can go through and say, oh, give me some data to unit test with, and it will give you data that complies with your model. So I thought that was kind of an interesting little twist for helping you build your pipelines.
Yeah, it's super neat. If you're a fan of Pydantic, this looks really, really cool. You get basically the type of errors you would get parsing JSON with a Pydantic model. It's the exact same error messages you get, but for data frame validation. So I think that's pretty cool.
Yeah, so it's nice and familiar.
Yeah, definitely. If you're a fast API person or Pydantic for whatever reason. Also, Patito, not Patio. I suspect it probably is. I want to start a trend. I want to try to put something out there in the world for people. If you've got something that could have multiple pronunciations, put just a little MP3 or something in your repo. Just it sounds like this.
You know what? I'm not sure that that's helpful, because you remember the whole how do you pronounce Linux debate back in the 90s? One of the, I think it was Slackware distribution I had, came with an MP3 of Torvalds pronouncing it. And of course, with his accent, it didn't solve the problem. So I'm not sure that an MP3 is actually the answer. Maybe just a little hyphenated where you want to put the stress of it. So
yeah,
or we can
I think I saw a GIF, or was it a GIF about it? I don't know.
Yeah, exactly. That's right. Just something to help us figure it out. It gives us something to fight about on the internet.
Yeah, that's right. Oh, let's make memes about it. Okay, so the next one is Polars IP tools. I'm pretty sure that's how we'd say this for.
Yeah, this one's less debating. Yeah, so this is a library by Eric Hutchins, and if you're playing with IP addresses, this could be helpful to you. It essentially provides a bunch of data frame methods for mucking around with IP addresses in a column. One of the functions it provides is private. This returns true if the address is a private network. So if 192, 168 or one of those groupings that's private, then you get true or false based back from it. Another method is in. So you give it a list of addresses with masks, and then it'll give you true or false for every IP address as to whether or not it's in that specific group of ranges. The library also integrates MaxMind's GeoIP address database, if you've got access to that, as well as the Spur VPN database, which contains information about what's a proxy, what's a VPN, that kind of stuff. So if you're doing a whole bunch of log management and you're dealing with all those IP addresses that are coming in your logs, and you want to use Polars to muck around with that and create reports, then IP tools might be helpful for some of that kind of stuff.
Yeah, if you're doing online sales, you want to know where the sales coming from, or where's the interest coming from. Say for marketing, this would be super valuable. Once a sale happens, often you can say, well, they put their address or zip code or credit card information. We can see that, but there's way more traffic upstream from that doesn't necessarily buy things, right? You can see where the interest is and so on. I actually don't use this library, but I use the MaxMind stuff over at TalkPython, because when you come to visit a course, I want to show it in your currency. Well, what is your currency? Well, it belongs to your country. Well, what is your country? You probably haven't told me, but I know your IP address. So let me see if I can figure that out and at least get it right most of the time. So yeah, this is cool. Right. Fuzzy match.
So
this is great. Goose geese, which is it? Which am I finding?
Exactly. So moving from IP addresses, which are very specific strings, to some more generic ones, the Polars fuzzy match library does kind of what you would expect from its name. The GitHub user's name was BNMock3. He didn't write out his full name, so that's what we're going to go with. His avatar, or their avatar, is delightful. I square symbol non-ASCII characters, which is funny. But so if you're not familiar with fuzzy matching, it's about approximate matches on a string. So this library comes with a function that returns a score based on the thing that you're matching. So let's say I had a series of strings that I wanted to match against the word car. And those that list had care and card in it. Those are close, so they might have a score of like 80 something. Well, frog, which has nothing in no relationship to car, that scores a null. So this allows you to sort of see how close you are. And the fuzzy matching routine that they're using is based on an underlying Rust library called Nucleo, which comes out of the Helix editor. So it's supported in a whole bunch of different ways. This isn't just some random guy on the internet. And it also has a bunch of a bunch of ways of specifying patterns, like submatches, starts with suffix matches, inverted matches, and more. I kind of like the suffix match feature, so it allows you to do fuzzy matching just on, say, the suffix part of the extension part of a file name and ignore the rest. So you can, whether they mucked up MP3 or MP4 or whatever. So that's kind of a neat little piece. And then along the same lines, the next one's Polars STR sim. It is so fuzzy matching is based on something called a distance calculation. And this essentially takes two strings and then gives you a value for, typically it's between 1 and 0 as to how close they match. So if they're identical, it gives you a 1. And if if they have nothing in column, it gives you a 0. The most popular of these is Levenstein distances, but there are other ways out there.
The Jacquard, for example, or the Sorensen dice or whatever.
Yeah, I wasn't even going to attempt that. So thank you. These kinds of calculations get used in things like, say, spell checking software. So if you've got something that isn't in the spelling dictionary and it wants to make a suggestion, then what it does is it runs one of these kinds of distances on a bunch of words in the dictionary, and those values that are close are the suggestions that it'll give you. So the Polars STR sim library, which is from a fellow Canadian, Jeremy Foxcroft, allows you to calculate these string distances on your data frames. As you mentioned, it supports a whole bunch of mechanisms, which I'm not even going to pretend to pronounce. Each of the calculators basically takes two column names and then calculates the distances between them, which makes it really easy to include in something like a with columns call, so that you can just sort of add this to your data frame and go along with your distance information. So if you're trying to do partial matching, either of these two libraries could be helpful for you.
Yeah, they seem really great. Just a little bit of a side note here. I think this is an interesting pattern with this Nucleo Rust library that is actually kind of the foundation of the Polars fuzzy match, right? I think this is something people should kind of keep their eye on out there. Is like, okay, so this is not super popular, but so you might think, well, maybe it's not going to work that well. But if it's just kind of a wrapper around something that is super popular, right? An example would be Granian. I had Giovanni on the show to talk about the Granian Python production worker process thing, and it's getting pretty popular, 3.5K, but you look at, say, UVicorn or something like that. But then really what it is kind of a wrapper around Hypercrate. Well, Hypercrate is way more popular,
right?
Written in Rust, right? Used by 360,000 projects and 400 contributors. Like, oh, okay, so Granian is kind of like an interface to Hyper in a sense, right? And that's also a little bit what's going on here. And so when you're evaluating these libraries, I think that's worth keeping in mind. What do you think?
Yeah, no, for sure. Like it's not that you can't create bugs in a wrapper, because you can create bugs in anything, but the less code, the less likely there's a problem. And if it's built, like you say, if it's just a thin veneer on something that is big and popular and well maintained, then the fact that it's a thin veneer becomes less important.
Right. Like, well, that veneer is not that popular. Like, that veneer doesn't matter that much. Okay.
Yeah.
Maybe you should encrypt it, though. If it has sensitive data, you should encrypt it.
There you go. And this is another one, actually, that we'll pretend we planned that. So this is another one which is a thin veneer. So if you want to be sneaky with your text here, Niazi Garagashli, which I'm sure I'm butchering, has written Polars Encryption. This library incorporates AES ciphers into Polars, providing encrypt and decrypt functions as expressions. So if you're mucking around with, say, personally identifiable information, or you just like sending other data scientists secret messages about your pointy-haired boss, then this little veneer could actually be fairly useful to you.
Well, I'm thinking of maybe there's like encryption at rest type of stuff you want to be having going on. There's a lot of different file formats that you can save in, right? I mean, there's CSV or Excel, but you don't really want them necessarily if you're doing like native polars, right? We have Parquet, PyArrow, other better types, right? So maybe you import some data and you then encrypt it so that file sitting on disk, somebody grabs it, like, so what? I mean, your app still has to know the encryption key and maybe decrypts it in a data frame in memory, but here's a really nice sort of back and forth library for that, right?
Yeah, and data frames are a perfect place to do that kind of thing. Encryption tends to be expensive, but data frames tend to be fairly fast about that kind of stuff. So you're going to outperform using a mechanism like this that's built underneath as a Polars plugin than, say, building a loop yourself and doing it. So it tends to, like you said, it gives you that safety, but it gives you it in a way that's a little speedier than doing it yourself.
Yeah, I don't remember if I spoke to Richie about this. Maybe I did, but I don't remember what he said if I did. That's for sure. Does Polars do parallelism automatically, or is there a way to ask it to do it easily, right? Because this encryption per entry in a column is one of the embarrassingly parallelizable algorithms,
So
right?
I know there are async pieces underneath. I haven't played with them myself, so I'm not sure exactly how you trigger that. I know, so Polars itself, although it's very much a Python library, the heart of it underneath is still Rust, and I believe that has been built so that you can get some of that concurrency. I don't know how easy it is to just turn that on. It hasn't been something. One of the things with concurrency, it's actually what I did my master's degree in, and the only thing I really remember is really don't do it unless you absolutely have to. I routinely ingest 1 million rows with Polars in a sub-second, so I've yet to need concurrency because the size of the data stuff that I deal with isn't in that petabyte range where it actually would start to matter. So there are mechanisms there, but I can't speak to them very well.
Yeah, I haven't done them either. So
Time to move on?
Yeah, it's time to move on. Apparently there are ways to do it, but it's not worth going over in audio. Okay, let's move on to XDT.
So sorry. Yeah, I wasn't being snarky there. I was heading
No,
for
I
the
know.
pun.
Of course.
This is a Datetime functionality library, and it actually comes from the Polars folks. So I think what they're kind of doing here is kind of like the contrib thing inside of Django, which is, we don't really need this. We'll keep it separate, but if you need it, it's there. It essentially is a collection. I think it's like a 10 or 12 functions that essentially are extra date stuff. For example,
last one was last commit was by Marco Corelli, who's been on the show before. Yeah.
Oh, there you go. So, for example, the date range function returns a series of dates and can be used to populate a column in data frame. So it takes a start and end date as arguments, and then will work with a variety of intervals and allows you to ignore weekends and holidays. So if you want to generate like a time series kind of thing, this will do that. The day name function returns the name of the day of the week, supporting localization. Similarly, there's format localized, and I think there's other stuff for months and things like that in here as well. The one I kind of liked, I've done a couple courses on astronomy because a colleague of mine is working on his degree in this space. So it always fascinates me when you move sort of sideways in a science and you're like, you're doing what? So this library supports calculating a Julian date, which is kind of like a Unix epoch, except day one is in 4713 BCE. And although this is fun for history buffs, it gets used in astronomy so that they can do time-lapse calculations as simple addition and subtraction. And so it's like Julian 1 versus whatever we're in now, which is Julian 6000 something. And so if you're, as strange as this may seem, if you happen to be working in that space, this plugin allows you to switch between Julian and back and forth. And then, of course, Julian dates also mean something completely different. So that gets confusing as well. But, welcome to software.
Yeah, welcome to date times in software for sure.
Yes, we had double so in date times.
Yeah, so there's some interesting things here, and I have some real-time follow-up here in a second. So It says blazing fast, written in Rust. Convert to and from multiple time zones, which is great. Format date time zones and different locales, Julian dates. And then there's a couple of things that are crossed off and say they've been upstream to polars, which is really cool. It's like, actually, this turns out to be important enough. It should just be in polars. So there's this cool interplay here for sure.
Yeah, I'm pretty sure this is somebody's playground. So I think they're maintaining it separately, and I think if it's something that's popular enough, it'll move up. But
right.
you know,
and it is in the GitHub. Sorry, it is in the GitHub Polars repos, not the organization, not just some.
Yeah, and that was kind of what I was about to say. Right back to your question about sort of a trust thing. Well, the people who write the library, when they write another library to go with it, you're probably okay.
Yeah, absolutely. Marco Corelli, this is my real-time follow-up, says, hey, some of these didn't fit into polars because they would have increased the size of the binary too much due to extra dependencies, right? So
that's
it's
great.
Like too heavy weight, but let's make it an extra. So
yep,
very cool. Nice.
That's a good reason to do it. Yeah.
Yeah, indeed. All right. Let's go and talk statistics a bit.
Yeah,
what's the chances of that, huh?
So from making from simple math to harder math, yeah. So let's say you're doing some audio signal processing and you need to pull some of the frequencies out, or you want to try and remove some noise. This process is called filtering. One way of doing this is to use something called a least mean square filter, which is a special calculation that tries to minimize the mean square of the error between the signal and the desired result. You too can sound like you know what you're talking about by reading a Wikipedia entry into a microphone. If most of what I said was meaningful to you, then the Polars OLS library might be your thing. This is by Azmi Rajab and performs least mean squares calculations using a variety of different mechanisms. Allows you to do this it allows you to do this as a Polars expression. And of course, the underlying code, like a lot of these, is Rust based, so it's nice and snappy performance wise. The expression even includes different ways of dealing with nulls, which is one of those things that gets in the way with real world data. So this library strikes me as one of those things that will save someone a whole lot of time. So if you happen to be that someone, there you go.
Yeah. It's excellent. I think in data science, there's a lot of this tension of, do I actually need to know the algorithm and the details of this, or do I just need to know that I can call this function and when I should call it? And I think that's a valid tension, right? Because if something, you call it on the wrong data and you get the wrong answer, but you're like, look, I've discovered life on another planet. Oh no, I discovered dust or whatever, right?
It's I was doing a bit of tutoring for a friend of mine's daughter a few years back, and one of the things I ran into is, you're allowed to use calculators now, which when I was a kid, calculators basically didn't exist and you weren't allowed to touch them. But now this is part of the math program. And one of the things we were talking about a lot is, well, if you don't know what answer you're expecting, then when it says 1,000 and it was supposed to be C10, you're not going to know you hit the wrong button. So I think that's kind of that. This is exactly what you're talking about. You need to understand it enough to sort of go, am I getting something back that makes sense? So if you just call the function blindly, garbage in, garbage out. But if there's a lot of depth to some of these things, and you could spend an entire career trying to understand it all, and that's not going to help you solve the problem you're trying to solve, right? So yeah, like you said, balance.
Mm-hmm. Indeed. What about pairing?
Okay, so this one's off the charts. So a pairing function is one that takes two natural numbers and maps that to a single natural number. This process can also be undone, so you can take a single natural number and find out what pairs could be used to create it. This is related to set theory and gets into that funky domain where you can start to talk about some kinds of infinity are bigger than other kinds of infinity. The Polars pairing library by Antonio Camargo provides 3 different pairing functions. I'm not even going to try. One of which is Cantor, that one I can pronounce, which allows you to pair columns in a data frame or unpair a result.
I've got the Sudzik and Hagen as well. Got them all.
There you go. If you Google around, you can find all sorts of articles on what this is and how it gets used in set theory. How you'd use it in your code is a mystery to me, but maybe I just didn't dig enough. But if you're mucking around and trying to understand Cantor pairing, why not? If, on the other hand, one of the things I saw come up a couple times with that some of these libraries are often used as examples for how to write a Polars library. So there are certain things you need to do if you're writing a plugin. And so some of these small libraries, as much as this might not apply to your day-to-day, because they're a small library, they can actually be helpful for you to kind of understand the structure of things, because you don't need to understand the math underneath this. That's just a function call, but you can see the structure of things out there. So sometimes something like this that is, why would I do that, could actually be a good lesson.
Yeah. Okay. Well, it seems like maybe encryption, I don't know. But yeah, if you're doing set theory.
It's, in theory, this has to do with hashing. In practice, I think there are better ways of hashing. So yeah.
Theoretical hashing. How about that?
Yeah.
All right.
So as a complete aside, there's several list items on the Polars package list use the little bear emoji in their docs. And I'm not sure if this is just my font, but it looks like a panda. And
it looks like a panda to me too.
Yeah. So to be clear, if polar bears and panda bears lived in the same place, panda bears would be appetizers, and they even come with their own little bamboo garnish. So funnily enough, I'm not sure if this is a strong signal, but not one of the ones that used the bear emoji was one I could get working on my system. So I don't know, for whatever that's worth.
Funny.
Anyways. So we kind of got into the weeds there. So now we'll step back a little bit and talk about a few things that are a little more higher level. The Polars list utils, good name, kind of describes what it does. This is by Travis Hammond, and it gives you a series of functions that operate on columns that have lists within the column. So one of the stronger uses here is something called aggregate list column element wise, which is a long function name, but it does aggregation operations on the values inside the list data, supporting the same kind of aggregation that regular Polars does. So you could do a mean, a count, a sum, or whatever on those things that are in the column. So the library seems to be coming out of the signal processing space, I suspect, because it supports a whole bunch of fast Fourier transform mechanisms, including applying them, getting frequency bins, linear spacing, and all that kind of stuff. The library also has some decent examples in its repo. This was obviously written by somebody doing something with audio, because there's a whole bunch of sample data and graph pictures and things like that on it. As a quick aside, this project explicitly required Python 3.10 through 3.12, but I was able to get it working using the ignore requires Python flag to pip. So I don't think there's anything. I was using 3.13 and there wasn't anything that was actually 3.12 specific. So if you bump into that, if you're playing with it, don't worry about that too much.
Interesting. Yeah, probably they just over constrain their requirements when specifying the package, right?
I ran into it with a couple of the other libraries that I tried out, and they actually didn't work. This wasn't that case though, so this worked fine.
Okay, yeah, very interesting.
And then
I hardly believe it. Believe it.
I love the image with this one. There's a nice biker going thing here. So this is Harley. This is by Tom Burge. And although the docs explicitly say it isn't associated with the bikes or the comic, there's a nice picture of a motorcycle in acknowledgement, and an acknowledgement that this is a port of a PySpark library called Quinn. So that's where it comes from. This is a catch-all library. It's got a bunch of different things. So, for example, anti-trim, remove all white space, and single space are all functions that deal with leading, trailing, multi-white space inside of strings. Approximate equal compares two columns for equality within a given threshold. So that's kind of useful if you've got a couple floats and, if it's within 10% of each other, then that's good enough. Multi-equals checks if multiple columns have a specified value. So, again, different comparison things. Div or else divides one column by another, but allows for a default value if the divisor is 0. So that's useful when you're not supposed to be dividing by 0. I'm told that's not allowed. And then there's some validation tools. It's just a good recommendation.
Yeah. No.
And there's also some validation tools, Boolean tools, and a few things in here that can help you get information about your schema. So nice little all told collection. And yeah, I love these kinds of things. There's a couple ones in the Django world that, there's one I wrote, and there's, the extensions one as well. These collections are often, I find these are the ones that often save me the most amount of time, because there's usually something in them that I'm going to use again. Because this is, it's written by somebody who was trying to solve some problem and just didn't want to do it twice.
Yeah, very cool. Yeah, I think that might be all over. That's
the list.
Our
that's the code list. Yep.
And I was thinking after we went through them, I might know if it were 10 or not, but I'm even more confused because we went down so many tangents. I don't even know whether some of them count. But I can tell you that those are a lot of helpful tools and libraries for people. So thanks for putting that list together and doing all the research, Chris.
Yeah, for sure. And, we only really covered a few of the plugins. The Awesome Polars list also has links to articles, links to blog posts, things on different interfaces for Polars on other languages that you can use to interact with it. So even over and above the libraries we talked about there's a fair amount of decent content there.
Yeah, absolutely. All right. Couple final calls to action. I'll let you have the final word, but I'll do a few for you. Check out your Django book. Very cool. Even has some HTMX in it. Check out your Polars course, which yes. I'll link to in the show notes, and is very germane to this conversation. And with that, people want to do some Polars, maybe want to level up a little bit with some of these things we talked about. What do you tell them?
It's a very approachable library. I think it's one of those things you can dig in fairly easily to. Not to say, hey, the course is very helpful, but the guides that come with Polars are also very, very readable as well. So if you're saving up to take the course later, hit the guides up as well. They can be helpful. And the community seems to be pretty good. I've seen a fair amount of your typical Python help each other out kind of space as well. So. It's a fun little library and very, very useful for solving some of your data science problems.
Awesome. Thank you. Let me do one more quick little shout out now that I'm thinking about it at the end here. Speaking of Marco Gorelli, I had him on recently to talk about Narwhals, which is a library that will help you bridge code between working with Pandas and working with Polars and other data frame libraries. So if you've got some code and you want to try out Polars on it, but it's mostly in Pandas or some other data frame library like, I don't know, Dask or something, you can check out Narwhals as well. And the episode is 480, so not too long ago. Anyway, one more thing, people, to help them get started. All right, Christopher, thanks for being on the show. Always fun to catch up with you.
Yeah, great. Thanks for having me.
Yeah.